which is 12-page biodata, but I have reduced to 1.5 page, and I will try again, third time to introduce you very correctly. So it feels an immense pleasure to be here. It is indeed my honor to make you introduce with today's guest speaker, Dr.Joel Gaikwad sir. As a speaker for this activity, he acquired his PhD in biochemistry and obtained MS education in microbiology. He has worked as postdoctorate fellow in Department of Molecular Biology and Immunology at San Diego and Boston. He is currently working as a professor in Department of Biology and Chemistry at Oral Roberts University, USA. He also has many awards and honors at his disposal that he got nominated as Faculty of the Year for the university. He has got Outstanding Faculty Award for Department of Biology and Chemistry. He also has got Recognition Award for Excellence and Leadership. He grabbed Dean's Award in Innovation in Teaching. He has total 10 grants under his belt at his disposal. He served as a guest speaker for various institutions and universities like University of Oklahoma, International Student Center URO. He has a very broad, wide horizon for area of research like cancer cell lines, biofilms, epigenetic gene regulation, and so on. List is very long. And he has working in various professional organizations like American Society of Microbiology, Tri Beta Society, Oklahoma Academy of Science. He has many publications and presentations of research paper under his belt. And this is very long actually, but I will mention just one book on his name, that QB Immunology, which encompasses allergy and hypersensitivities. Actually, as introduced, as I told you about the twice, but one more important interaction remains, that he is very actually indirectly and unknowingly familiar with us, because he is nothing but the mama of Mahima madam. So please put your hands together. Because we are really very much eager to listen to your talk on the modern trends in molecular biology and the area in which actually he is interested in, that is the Crispr technology. So put your hands together, welcome him once again. Okay, so as per the tradition and the culture of our society, of our country, that is very customary and mandatory upon us to felicitate. Actually, this is just not actually the big universal felicitation, but I hope that you will accept a small felicitation and small offering with the bouquet. So I would like to request the head of our department, Dr.Joel sir, to please felicitate our today's guest speaker, Dr. Joel sir.
Well, good morning.
Good morning.
सर क्या लगा लूज है और कहीं इसमें थोड़ा चलो लैपटॉप थोड़ा तो गया
It's almost midnight for me now. In my back home country, this is midnight, so I'm almost half asleep. Since morning, I have almost 5 cups of tea just to keep awake. So if I fall asleep, don't blame me. First of all, before I get started, I just want to really appreciate the opportunity to come here and just talk to you heart to heart. I will spend little time in talking about the latest technology, CRISPR-Cas9. How many people were able to come for my talk yesterday? Okay, we got 2 people, 3 people. Okay, so we have a couple of people in there. So I will not repeat that, but I think I will just give you kind of what I call as a summary of what we are trying to do there and what the technology is available. What I'm trying to do is that I think I have a passion for young people like you. I do these talks even back home in my country to encourage people like you to go go into science, education, and other stuff. So we'll talk about that later on. Okay? And I'll tell you what my passion, where it comes from. Okay? Before I do that, again, once again, thank you very much, sir, for inviting me here to this place and share my experience, my knowledge with you guys. And this is home away from home for me. Okay? Also because my Mahima is here. Alright? Okay. Let's get started with the technology very quickly. I don't have any slides, but I hope you'll understand why I want to come to terms with that technology. This technology is called as CRISPR-Cas9. Okay? How many people know what bacteria are? I know it's zoology department. What bacteria? Are bacteria prokaryotic or eukaryotic? Prokaryotic, right? So, do bacteria have an immune system? Do they have? So what kind of an immune system do they have? What kind of an immune system do they have? Let me ask you an easier question. Do bacteria produce antibodies? Do they produce antibodies? You can be wrong, it's okay. Do they produce antibodies? They don't produce antibodies. Okay? We produce antibodies. What are antibodies? When we get infected with a pathogen, our body looks at the pathogen and the B cells in our body look at this pathogen and produce antibodies specific to that specific pathogen. Now that immunity is called as adaptive immunity. Okay? So we are adapting to that immunity based on what it is. Okay? Now until 1964, we were under the impression that only eukaryotes such as you and I have the ability to produce antibodies or adaptive immunity. Okay? But after that, there was a discussion and they found out that some bacteria have a genetic makeup which was very weird. It did not look proper. Okay? It had a very unique structure to its chromosome and people did not know what it was. Okay? I don't even have a chalk and a board, otherwise I would draw something for you. Can I have something to write? Yes. I'm a teacher at heart. Okay? What is getting ready for that? So if you look at the structure of the of this structure, I'm not an artist. So my lines are okay. Once I draw this, then I think it will be okay. Let's take the words. This I'm going to just leave it as SPA. SPA. And SPA. So when they sequence the DNA of a human chromosome, bacterial chromosome, they found that there was a pattern. There was a pattern. The pattern was that there was a section which was repeated 1, 2, 3, 4, 5, 6, on and on and on. This sequence did not change. Okay? So this, because it did not change and it was always repeated, and that's what it was called as a repeat sequence. It was called as a repeat sequence. All very closely. Okay, once I've done this, then I'll go to the technology. This sequences in between was different. Okay? sequences that are different, they are actually derived from an infection of a virus particle or a bacterial phage. You follow? So if you look at the sequence, if you look at the bacteria, this bacteria is infected by a phage, and when this phage infects this E. coli or any other organism, it takes part of this chromosome from this phage, breaks it into small pieces. You follow? You take this small piece of the phage DNA and you put it in this sequence in here. Are you following? That is called as a Crispr array. This is called as a Crispr array. That's what the discovery made. Okay? Now what happens is that if you get this sequence in the bacterial chromosome, this bacterial chromosome along with this, what are the three stages of information of flow of in bacterial cell or any cell? What is the flow of information? What is central dogma? Do you know what the central dogma is? What is it? Very good. Okay. So DNA replication, transcription, and translation. Right? That's what you're looking at. So this is going to be transcribed first into RNA. So when this is transcribed into RNA molecule, which I'm not going into detail, but I'll show you what happens. So if you take this sequence, when I transcribe it, it gives me a part of RNA. This will combine with something else which I'm not going to talk about. It is on this part of the chromosome, and that is called as CRISPR RNA. So the CRISPR RNA and this RNA, it makes a